Okay, factoring, one of the biggest topics in math in high school and in college. Okay, so if you're planning to go to JJC, Moraine Valley, any college in the world, okay, if you're taking Math 098 next semester, or next year, which we haven't talked about yet, but if you are, factoring is like probably one of the biggest skills you're gonna have to know going into those things. College, Math 098, anything. Okay, no matter what, factoring is going to come back, I promise. So if you were to buckle down and get serious about anything, this is definitely the part that you want to get serious about, factoring. Lots of factoring, lots of ways to do factoring. So hopefully, I know that you guys did it last year, maybe for a week, but it's hard to catch on to. So we're going to spend time on it this week. And then in chapter 6, we spend more time on it. And then next semester, when we do the Math 098 prep, which we do like a whole unit on it, maybe like 2 or 3 weeks, we do it again. Okay, because that's how important factoring is. So we want to make sure that we really grasp it and really pay attention. Pink packet up there, yeah. There you go. Okay, so it says, this is the easier factoring today. So it says, recall, factors are numbers that can be divided evenly into any number. So for here, number 24. 1 goes in there, 2 goes in there, because 2 divided by 2, 2 divided by 3, they all go in there. They're all divisible. They all divide into it. Now there's this thing called like a factor rainbow, where they're basically pairs. 24 divided by 1 is 24. 24 divided by 2 is 12. 24 divided by 4 is 6. You know what? That was kind of what we were doing on Friday in those tables. We're going to be basically doing the same thing. So let's do 16 together. I have 1, and what's 1's pair? 1 times what number is 16? 16. So 1 and 16, I'm going to leave like a little gap. Then let's do 2. This is just like those mod tables. What's 16 divided by 2? 16 divided by 2. What do you think? 8. Thank you. And then 3 doesn't work. If you do 16 divided by 3, it doesn't work. This is exactly what we were doing Friday. 16 divided by 4. What's 16 divided by 4? That's 12. Careful. That's 24. 4. 4 times 4 is 16. And then you're done. Because you came to the middle and there's nowhere else to go. Because 4 and 4 is the pair. Let's do it again. What is 32 divided by 1? 32. Okay, 32 divided by 2. Either use your calculator or your brain. 32 divided by 2. You got it? What did you say? 16. It is 16. Very good. Okay, 32 divided by 3 doesn't work. If you try that in your calculator, 32 divided by 4. What you got? 32 divided by 4. 8. Okay? And then 5 doesn't work and 6 doesn't work, so we're done. Okay, so really that's our close gap. And you can see that it makes it easy when you do it that way, where you're doing like that rainbow piece, where otherwise you're going to have to keep testing all these numbers up to 32, and that's a pain in the butt. All right, 1 and 64 work for 64. 2 and what number? There's 2 ways to think of this. 64 divided by 2, or what times 2 gets me 64? Either way works. I just like the division game. I think it's easier. 64 divided by 2. 32. Very good. Okay, 3 doesn't work. 4 does. What's 64 divided by 4? Kind of closing this gap. 16. Okay, 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 does. And it's 8 times 8, so we're going to close it up there. So you can see how it kind of just like comes to the middle. Now, when you're talking about greatest common factor, or what we shorten it as GCF, it's whatever number is the same, but it's the highest one. So what is the highest number that's in all 3 of these? 16. Okay, so 16 is what we're going to be going with here. So I'm going to write 16 for my GCF. If you want to circle it, you can. That way you know you're looking for the highest number or variable in the future that goes into all of the terms that you're working with. That has no remainder, divides them evenly. Okay, so that's kind of prep work for this factoring thing. So now let's read about what's coming up. The polynomial expressions on the left side of the equation below contains a GCF. That's what a greatest common factor is. The question is, what do all the terms have in common that can be divided out? So I'm going to star this, underline it, highlight it, whatever, because that's the ultimate question when you're doing factoring. What do all of the terms have in common that can be divided out? So look at the coefficients and the variables. So look at like the numbers and the letters. Divide each one of the by the GCF and think of it as undoing factoring or undoing distributing. Okay, and I'll show you what I mean by that. So the question is, I always go off to the side and I write off what my GCF is. So my GCF, what number goes into 36 and 16? What's the highest number that can divide into both 32 and 16? 8 doesn't go into 36. 6 doesn't go into 16. 4 goes into both of them, yes. So 4 does go into both of them. Now you could have thought 2 because they're both even, but if you need to go off to the side and you need to write out the factors, you can, like 6 and 6. Okay, you can write all those factors out if you want. It's up to you. You can go up here and rewrite all of that out if you want to. Okay, now let's talk about the variables. You got to look at each one. We have x squared and x. If this one has 2 x's and this one has 1 x, what's the max amount I can take out and it'd be okay? One of them. So x, and then the y as well. So that's our GCF, 4xy. Again, we're going to take it slow. Take it slow. We're first going to identify the GCF. 4 divides into both. The hardest part, in my opinion, is the numbers. Usually it's the letters, but I think that the numbers are easier. Because the variables, it's the smallest power. That's it. That's why it's x and then y. So let's go ahead and divide each one out. So I'm going to divide this guy by 4xy and divide this guy by 4xy because that's the GCF. Now here's the part where people always forget. They forget to rewrite the GCF out in front because when you distribute, you'll see why. So I'm going to put a little arrow. The 4xy, whatever you're dividing out, needs to come on the outside of the parentheses. And I'll explain what all of this is after the first round. Now here we go. What's 36 divided by 4? 9. Okay, so that goes there. If I have 2 x's on top and 1 x on the bottom, how many is left and where is it? How many x's are left? 1. It's on the top, so I'm just going to write the x. And look, the y's are gone, so I'm done with that one. What's 16 divided by 4? 4. And then look, cancels, cancels, and this is my final answer. That's what factoring means. You're factoring out a GCF. Now, I'm going to show you what this means and why this works. The reason why we do this is for us to start solving for equations. Down here, we'll start practicing it. And what that means is you're finding the x-intercepts. Where are they? So let's take a look here. If you were to distribute, you don't have to write this down, but if you were to distribute back in, you should get the same answer. 4xy times 9x gets me 36x squared y. If you multiply 4xy times 4, you'll get 16xy. That's what you're doing. You're reversing it. It's like they're inverses of each other. They're the opposite. All right, let's do it again, but now we have 3, so we got to be careful. So I'm going to first figure out what my GCF is. Okay, we have 12, 28, and we have 8. Does anyone know what the GCF is going to be? We know that they're all even, so it's absolutely going to be 2, but could it be higher? We don't know. Let's figure it out. See if you guys can figure out what the GCF is, what number. 2 definitely goes in there, but is there a higher number that goes into 12, 28, and 8? 8 would not divide into 12. If you do 12 divided by 8, it would not work. 4 definitely goes into all of them. And you can just start low. You can do that. You can do like 12 divided by 2 and then 28 divided by 2. And if they all work, then you're good to go. Okay, now let's talk about the variables. I have 5 x's here, 4 and 2. What's the max amount that I can pull out of all 3 of them? How many x's can I pull out total? It's always the lowest power. 2. Here's why. If there was this right here, like plus x, I'd say 1, yes. But if you want to make a note for yourself, it's always the lowest power. And that's why it's x squared. Because if I say x cubed, if I can pull out x cubed, that's not true. He only has 2 to give me. So I can't pull out 3. That's why it's got to be 2. So now let's go ahead and write that divide each one by 4x squared. Here we go. And again, once you get better at this, maybe you won't have to write all these steps out, but for now, we are. So I have 4x squared times something. There's going to be 3 spots here. Here we go. 12x to the 5th divided by 4x squared. Well, what's 12 divided by 4? 3. And then if I have 5 on top and 2 on bottom, how many is left? 3. I'll explain that. It's like if I did this off to the side. Again, you do not have to write this down, but just for visually. 1, 2, 3, 4, 5 on top, and I have 2 on bottom. Gone, gone. I have 3 left. That's basically what you're doing. You're crossing those out. Okay, minus, what's 28 divided by 4? 7. And then x to the 4th, and divide by x squared.
2.
X squared, very good. And then these squareds go away, plus, what's 8 divided by 4? 2. And we're done. And you can always check your answers by distributing back in. All right, so that's kind of just like a warm-up for those factoring, the GCF. So if you ever say, hey, factor out the GCF, that really means take out something that's common between all 3 of them, or all 2 of them, or how many you have. Okay, now we're going to do the same thing. Those ones are tough. Now we're actually going to be working with like easier ones, but we're going to start solving. So it says factor out the GCF and apply the zero product property to solve. All that means is set all the factors equal to 0. For example, I would set like this one equal to 0 and that one equal to 0 because those are called factors, and I'll explain more when we do a problem here. So let's first look at this first one. What is the GCF between 2 and 4? Like what number can I pull out? A 2. Good. Yeah, that one's pretty easy. And then how many x's can I pull out? What's the lowest power? Careful. 1. And here's why. Look, this guy, if you want to draw this in, that means that there's 1 there. There's only 1. So that really means this guy has 2 x's, this one has 1, so I can only pull 1 out. Because again, you can't pull 2 x's out of 1. Like I can't do this. I can't do that. Then there's 1 on the bottom, and then that gets really confusing, trust me. Okay, so remember, that's really what you're looking for. So now let's go ahead and divide each one out. Divide by 2x, divide by 2x. So I got 2x times something equals 0. Here we go. 2 divided by 2 is 1. That goes away. I'm just going to cancel it out. X squared divided by x is what? 1x. Good. Okay. 4 divided by 2? 2, and the x's goes away. So you're dividing them out. You're dividing it out. Again, if you double check it, if you distribute, you'll get this back. Okay, now this is the new part. You set each factor equal to 0. So that's one factor and that's another one. So 2x equals 0 and x plus 2 equals 0. So those are my 2 factors. Okay, almost there. What do I got to do to both sides to solve for x over here? Yeah, divide by 2. So now we're going back to algebra, guys. We're not really working with graphs as much as we did. So x is 0 is one of my answers or one of my solutions. Okay, now what do I do for this next guy? How do I get him by himself? Yeah, I subtract 2. So I'm going to subtract 2 to both sides. It goes away. And I get x equals negative 2. Okay, you can take a breather here because it could be a lot of work. Because we're going from graphing, which is a totally different part of the brain than it is to doing algebra. Okay, visual learners versus not visual learners. Okay, this is very procedural, very, very algebra based. Whereas last part 1 of chapter 4 was all visual graphs. So it depends on who you are. You might be better at both. You might be better at both, or you might be better at one than the other. It just depends. But I promise we'll get you there. Okay, I want you to attempt to do number 2. Okay, at least find the GCF. Let's go there. Let's find the GCF together, and maybe you can go from there. I will say that whenever you have a negative all the way out in front here, you have to pull it out. It makes life easier, I promise, just trust me. So let's do the GCF together. Negative something. What number goes into both 4 and 16? 4. And how many x's can I pull out? 1. So hopefully from here, maybe you can follow the process and see if you can get to this answer. I'm going to give you a couple minutes. I'll walk around, see how you're doing. Now see if you can look at the example next to you and see if you can follow it along. That's a really good skill, is being able to look at an example. Now take a look. Again, it's a process, and I know it's tedious and it's strange. So I'm going to write the negative 4x on the outside. I'm going to set it all up and just copying everything down. You can't see that, huh? Okay, so the negative 4x, because that's what the GCF is. That comes out. You have to write him outside. Now here we go. I'm going to do it in blue. I'm dividing each one by that. And you don't necessarily have to write that in if you understand what you're doing. But until you understand, I would write that in so you know what you're doing to get the parentheses. So by dividing out, negative 4 divided by negative 4 is 1. So I don't need to write that. X squared divided by x is just x. And maybe like I'll draw an arrow so you know where that's coming from in your notes. Now, 16 divided by negative 4 is a negative 4. And look, the x's go away. And I can draw an arrow there so you know where it's coming from. So just going in order, guys. Going from here in order. Going left to right. Now you could divide this side by negative 4x too, but you'll notice that every time you're going to get 0. So there really is no point to just make that work for yourself. Okay, now, in yellow, we have to set him equal to 0. And in blue, we have to set him equal to 0. Or if you like to underline, sometimes people like to underline, that's fine too. So I have negative 4x equals 0. And x minus 4 equals 0. Again, you're finding those solutions. You're finding where, I'll tell you exactly what it means. So what you're actually figuring out is where it crosses the x-axis. You're figuring out on the graph, I'll show you in a second actually. I divide by negative 4, that goes away, I get x equals 0. Here I add 4 to both sides. For which one? The first one? Here, 16 divided by negative 4 gets me a negative 4. You gotta be careful. So I add 4, goes away, I get x equals 4 is my final answer. Okay. You technically could check your answers by plugging it in and see if you get 0. Like if you took 0 right now and plugged it in, you get 0 plus 0. Well, 0 plus 0 is 0. You got it right. If you plug in 4, you're going to get the same thing. Okay, you can always check your answers. Again, this is a very tedious process, and this is why people don't like factoring, but I'm telling you right now, please stop being scared of it. We'll get through it together, okay? I'm just trying to prepare you for next year and for college. If you're going to JJC or Moraine, I'm telling you, it's not going away. You might as well really try to focus on getting it now, okay? And again, the more you get used to it, the faster you'll go, the more steps you'll miss, or you'll take away. Like me personally, I don't write any of that. Because I know what the process is. I know what I'm doing. I'm writing out the GCF on the outside and dividing each one out. And maybe I'll show you that way if you don't like to write as much, just for the sake of trying new things. What is the GCF for this one? Let's see if we can do it without writing all these steps. Can you tell me what the GCF is of all of these? For number 3. Is there a number? No. What about a letter? Yeah, there's an X. So I'm going to write the X on the outside. Equals 0. Again, if you don't like writing all that work, it's just do it without writing it all out. X squared divided by x is just x. Negative x divided by x is what? Negative x. Careful. What's x divided by x? X. What's 2 divided by 2? 1. So whenever you divide something by itself, it becomes 1. So if this is your route, you don't like writing all that stuff, that's okay. But you need to understand what you're doing for that to happen. But for those that need it, I would maybe write out at least this step. You don't have to write out GCF and tell me what it is. You don't have to do that. It's just whatever works for you. Okay, now we set each one equal to 0. X equals 0 and x minus 1 equals 0. So that one's already done for us. We didn't do anything. But now we have to add 1 to both sides, and I get x equals 1. So what you're actually doing, like so that you understand why we're doing this and what this means. This means on your graph, this is where it crosses the x-axis, and this is where it crosses the x-axis at 1 and 0. That's really what you just figured out, where it crosses the x-axis. And you know it's concave up, so it would look something like this. Now, you obviously don't have to know that. You don't have to write it even. I'm just telling you what it means. You found out where it crosses you found your x-intercepts is really what you found. Okay? Questions, comments, concerns on that one, on these? You sure? Okay, go ahead and flip. I feel like we can flip to the next one. Okay, now, we're going to take this part. This part is actually, I think, easier if you did well on Friday. This is why we did Friday. So it says, rearrange if necessary so it's in standard form. That just means like x squared plus x and plus a number. Okay, just making sure it goes in order here, like 2, 1, 0 is really what that means. Then it says list all the factors of C. Okay, so this is exactly what we did on Friday. Here we go. What multiplies to 3, that's that C value, that's C, and adds to the middle term, which is 4. So exactly what we did on Friday. What multiplies to 3 and adds to 4? Well, we can list out our factors. Let's say 1. So 1 and 3. Is that going to get me 4? Yeah. What are their signs? Is there a negative there? Are they both positive? What's going on? Yeah, so I have positive 1 and positive 3, and I'm going to circle it. I'm going to call those like my magic numbers. They're the numbers that's going to make this problem work. Now, when A is equal to 1, that really means when this right here is 1, you can do the trick I'm about to show you, and you want to know how to do this trick because it makes your life so much easier. If you have to do it the way that we're going to learn tomorrow, every time it's going to take you a very long time. So when A is equal to 1, which is right here, when A is 1, you can do this. Your factors are x plus 1 and x plus 3, and that's coming directly from here, and that's why I told you guys I really like when you write your signs because it helps you realize what sign you need to put there. And then equals 0. And then look, we're almost there. Okay, so this was actually not that difficult. So now we have to set this one equal to 0, x plus 1 equals 0, and this one. Give you a second. I'm sure your hand's cramping up because mine did when I was making my notes yesterday. So let's talk about the first one. What do I got to do to both sides to get rid of this 1? Minus 1. So I get x equals negative 1. Done. What do I got to do to this side? This one. Yeah, subtract it. So I get x equals negative 3. And we're done. You found them. You're done. So that one actually might be a little bit easier if you like the tables that we practiced on Friday.
I wasn't in the classroom.
You were not, so I would definitely watch the video if you need to. Okay, so that's why we took the time to do this. So let's see. It's always that last term, so 12. What multiplies to 12 and adds to 7? You can make your little chart off to the side. I don't care where you write on your notes, but make it somewhere. Now, if you need to make sure that you understand where that came from, you can even put like an M here and A there, whatever works for you, but at least you know where it's coming from. So now, if you don't know that off the bat, you can make your chart. Some of you won't even need to make the chart at all, and you can just do it. So I have 1 and 12 for those that were gone. That's not going to work. Let's do 2. What's 12 divided by 2? 6. That's never going to add to get 7. 6 plus 2 is 8. It's not going to work. Gone. But 3. What's 12 divided by 3? 4. Is that going to add to get 7? Yes. So I'm going to come over here, and my signs are both positive. And we're done with it. Now we actually know what our factors are. We're going to use our magic numbers. Again, some of you may not even need to make the chart at all. Like me, I literally go straight to the end because I know what's going on. But you might not know right now, but in the future you might. You're just getting yourself used to it. And the more practice you do, the better you get at it. So all I'm going to write, x plus 3, because that's one of my magic numbers, and x plus 4, then equals 0. Now again, if you're someone that knows what's going on, you can skip right to the end, and I'll show you that way now in case you are that person. what makes x plus 3 equal to 0? What number would I have to plug in here? Or if you plug in 0, you'll get 3. Like what number? It's always the opposite sign. If I have x plus 3 equals 0, what would be your answer when I solve for it? Yeah, -3. And if you notice, it's always the opposite sign. So what makes this one 0? -4. So what I was trying to get you guys to see was eventually when you get better at this, you won't have to write this step right here. You can go right to here if you know it. I'm not someone that's going to require you to show me every single step. I don't like that. If you're a teacher, you should never be that way. If you can do things without showing some steps, that's awesome. I would want you to do that. I'd want you to go from here to here. Because that means that you understand what's going on. You can do it in your head. But if you need to write out, you write out. Okay? I don't like number 3 and number 5, but I am going to do one of them. Okay, number 3. So this one's kind of annoying because if you look, the x squared has a negative. That's a no-no in math. Okay, the x squared needs to be alone. He needs to be able to just be by itself, and it needs to be positive. So really that means is that you need to factor a GCF out first. Okay, so that means I'm going to divide each one by -1. Okay, and when you do that, it just disappears, because here we go. It changes to x squared, changes to positive 13x, changes to positive 40, and 0 divided by -1 is just 0, so we're done. Now we're back to what we just did on the last problem. You just needed to get rid of that -1. So now from here, I want you to try this. What multiplies to 40 and adds to 13, and see if you can take it from here. What multiplies to 40 and adds to a positive 13 is where you're going. Again, go in order. I know there was a couple people that were not here Friday. Just go in order. 40 divided by 1 is 40. It's not going to work. 40 divided by 2 is 20. It's not going to add to get 13. 3 doesn't work. Try 4. 40 divided by 4 is 10. Still not going to get me 13. Then do 5. Again, going in order, playing the division game is a lot better than trying to figure out the numbers in your head if you don't know it right away. Oops. When you're done and done only, you can look up. But please don't hurt yourself. Actually check your answers. Don't jump ahead. We're only going to do one more, and then I'm going to give you time to work on your homework, but I need you to work on your homework because this is a harder topic, and it's very detailed and very tedious. Okay, but I'm telling you, once you have it in that brain, it won't go away. I still remembered it when I came back, even after college. But I will tell you that it was harder when I was in high school to do this because they did not have the methods that they have now. When I learned it in high school, it was all guess check, guess check, guess check. Tried it, didn't work, erase it, do it again. Try it, didn't work, erase it, do it again. Now we have this awesome method, which we'll learn tomorrow, on how to do factor by grouping when it's a harder number in the front. Okay, questions on number 3, how I got these numbers. Okay, we're going to do 4, and then I'm going to call it a day with you guys. Now this week, I don't have bell ringers again, but here's why. Because this stuff is harder, I don't want to waste time on a bell ringer. Okay, so I want to make sure that we have enough time together to spend on the notes. And if you notice, the notes will have warm-ups in the notes. So we're going to do them together in the notes, or some of them by yourself. Okay, so here, what multiplies to what number? Sometimes the hard part is just figuring out this. What number am I going to multiply to? 21. And add to what? Just 10? Careful.
Oh,
Negative 10. Good. Make sure you make that. That's why I wanted to make sure we went over number 4 because that negative is attached. Okay, so again, in order, if you weren't here, 21 divided by 1 is 21. It's not going to work. 2 doesn't work, so I'm not going to do it, but 3 does. What's 21 divided by 3? 7. These are going to be the numbers I'm going to use. But the question is, what are the signs? I need a negative 10. What is the only way to get a negative 10 with this?
7.
Yep, and what? What about,
3.
so if you do negative 7 plus 3, you get a negative 7, 6, 5, 4. You get a negative 4.
So -3.
Yeah, there you go. So now you found them. Because look, negative 7 times negative 3 is a positive 21. But then when you add them together, you get a negative 10. You could always verify in your calculator if you need to. So here we go. X minus 7, x minus 3 equals 0. That's what I call my magic numbers. This only applies when a is 1. I'm telling you tomorrow there will not be an a equals 1 here. It'll be like a 3, so it'll be a little bit harder. So what does this one equal to then? See if you can just jump to the end. Yep, and then what about this one? Yep. Again, if you can hop right to there, that's awesome. I want you to skip steps. However, if you're not there yet, please continue writing it all out. Okay? All right, cool. You have a long time. You have like 15 minutes. A little bit more than that. Okay?